Uh, Friends, welcome to all of you. Today, I want to speak on the fundamentals of agricultural meteorology and a general introduction to the science of agricultural meteorology. You know that agricultural production depends upon four factors, that is, the soil, genetic material, weather, and management, that is agronomy. Actually, of these four factors, we can manage soil with some amendments. We can manage the genetic material. We can choose the kind of seed that suits best. We can they evolve management practices by trial and error. But what we cannot manage is weather. We have to accept weather as we receive it. That means as if it behaves. So the problem is, the weather is a not the is something not the same throughout the year. It changes from time to time during the day, from day to day during the season, and from season to season. So there is, if you take an year as a whole, you find that there is lot of variation in the weather during the 12 months of the year, or 52 weeks of the year, or 365 days of the year. And then when what scientists in the earlier days, when people were not able to know anything about meteorology, they tried to evolve understand the behavior of weather by analyzing historical weather data. That means they used to consider the averages, the deviations, variations, and so on, and try to identify the seasons during which comparatively more stable weather that is suitable for agriculture can be expected. That is how they evolved the cropping systems that are suitable for different agroclimatic regions. As you know, that we grow crops for not for the total biomass. We grow crops for the economically important part of the biomass, that is seed, grain, or pod, whatever it may be. So that the fraction of economic part, economic proportion of the total biomass that contributes to the yield that contributes to this yield. We call it as the yield. That means the total contributes to the economy is called yield. So that means this yield is directly proportional to the amount of water used by the crop up to a particular stage, up to a particular level. Beyond that, any excess of water you supply to the crop beyond its requirement may even lead to reduce the yields. Then another important factor they found is that the grain yield is directly proportional to the total solar radiation intercepted by the ground, because the water used by the crop depends upon the amount of solar radiation that is available. See, if the solar radiation is less, cloudy skies are there, the evaporation will be less. If there are clear skies, the evaporation will be more. During summer season, the temperatures are high, the evaporation increases. So the evaporation of the crops, the evaporation process depends upon several factors like wind speed, temperature, relative humidity, and incident solar radiation. That means more solar radiation you get, greater will be the evapotranspiration. When the wind speed increases, the evaporation increases. Similarly, when the humidity decreases, that is, the moisture content in the atmosphere decreases, the evaporation increases, and so on. So, what happened is they tried to develop the relationship between the weather parameters and the evaporation. But actually, what happens in reality is the total evaporation that depends upon the free water surface. That means if there is water only and no crop, standing water, then the amount of water that is evaporated from the atmosphere, we call it as evaporation. But in the case of crops, the crops interest do not crops do not require water all throughout the stage of its growth at the rate of the evaporation which we observe from free water surface. Why? Because these crops, when we sow them, then it will be we sow the seeds on the soil. There is nothing like crop in the soil. Then at that time, the evaporation of water takes place from the soil, which we call it as soil evaporation. And then, when the seeds germinate and seedlings emerge, what happens? You find that the, the small leaves that are emerging from the seedlings will start intercepting solar radiation. So, the amount of water used by the crop depends upon the amount of solar radiation intercepted by the leaf surface on the crop. So, as the crop gradually grows and reaches vegetative phase, it fully shades the ground. At that time, the the water used by the crop will be at the same rate as the evaporation. So, when the crop fully shades the ground, it is only evaporation from the crop, and the evaporation from the soil is almost negligible. And the combined loss of water from due to evaporation from the soil and evapotranspiration transpiration from the crop, we call it as evapotranspiration. Evapotranspiration means the amount of water uh, evaporated from the soil, that is soil evaporation, plus the amount of water evaporated from the crop surface, that is transpiration. So the when we take the combination of these two, soil evaporation, transpiration, we call it as evapotranspiration. So this evapotranspiration is one of the important parameters in the agricultural meteorology. If we can monitor the evapotranspiration regularly, we will know how much of water is used by the crop in relation to its actual crop water need. And then we see how the water used by the crop is affecting ultimately the total biomass produced and the crop yield we are getting. So for that, actually in 1948, two scientists, particularly Thornthwaite from USA and Penman from UK, have developed the concept of what is called potential evapotranspiration. What is potential evapotranspiration? It is a defined potential evapotranspiration as the amount of water you evaporated from the soil plus transpired by the crop when the crop is fully shading the ground and there is no shortage of water, there is no limitation of water. So that means for potential evapotranspiration, two conditions are required. One is the crop fully shades the ground, and second is the crop will be able to transpire water at the same rate as the potential evapotranspiration. So by knowing the potential, to calculate the potential evapotranspiration, they have developed empirical relationships because we know the parameters that govern the evapotranspiration process. The evapotranspiration process is governed by the stage of growth of the crop, the soil moisture, then the atmospheric humidity or then the temperature, then the solar radiation. Actually, we say humidity, but theoretically, it's not the humidity we depend upon for evaporation. It is the vapor pressure deficit. That means, what is vapor pressure deficit? That means at a given temperature, if the air is fully saturated, then the water vapor pressure in the air, we call it as saturated vapor pressure. That means that is the saturated vapor pressure indicates the limit at which the air can hold the maximum amount of water vapor. When the air is not fully saturated, the vapor pressure, the vapor, it is, we call it as only vapor pressure. It's not saturated vapor pressure. So the difference between actual vapor pressure and the saturated vapor pressure, we call it as vapor pressure deficit. See, saturated vapor pressure is the amount of water vapor, the pressure exerted by the water vapor present in the air when the air is fully saturated with water vapor. Vapor pressure is the actual vapor pressure is the pressure exerted by the water vapor in the air which is not fully saturated. So the differences between vapor pressure, saturated vapor pressure, and the vapor pressure, we call it as the vapor pressure deficit. So, actually, in reality, the vapor pressure deficit is the whole parameter that governs the process of evapotranspiration. Though the vapor pressure deficit depends upon, in turn, on radiation, humidity, amount of water present in the soil, and so on. So, what is most important is the first and fundamental thing we need to know to understand the crop growth. That is the amount of biomass produced by the crop from time to time, and ultimate total biomass and the grain yield only by monitoring the amount of water used by the crop from time to time, from sowing to harvest. This is so, that is very important. Then, in order to, because if we cannot directly measure the water used by the crop from from sowing to harvest using any instrument, the other way is to calculate it depending upon the stage of growth of the crop, the weather parameters like temperature, saturation, vapor pressure deficit, the atmospheric radiation, wind speed. That is very important. So here what I am trying to tell you is that we have developed a technique. That means the scientists have evolved a technique of monitoring the water use of the crop depending upon the weather parameters theoretically. That is very important. So this theoretical estimation of evapotranspiration from the crop will be used to ultimately decide how much of biomass can be produced, how much of economically important yield can be obtained. That is about the growth of the crop. Growth of the crop means the rate at which the total biomass develops from time to time, from sowing to harvest. That is called the growth of the crop. Then we also talk of development of the crop. Development of the crop means the crop after sowing from the from the date of sowing to the date of harvest, it undergoes through different phenological stages. That means first stage, there is germination of seeds. Then there is emergence of seedlings. Then after emergence of seedlings, there may be appearance of tillers. Then, after appearance of tillers, there may be uh, complete vegetative growth. And after completion of vegetative growth, what you find is the reproductive organs of the crop start appearing. That means the crop start flowering. And then after flowering, there will be grain formation or pod formation, whatever it may be. And after pod formation, the crop, the pods or the grains gradually mature and attain physiological maturity. After physiological maturity, it slowly the crop doesn't require much water, so you find that there is a lowing of leaves or drooping of the leaves, the leaf area decreases, and then what you find is ultimately there will be a stage when the crop is ready for harvest. That means that is harvest. So the number of stages through which the crop grows completes its life cycle. We call it as phenological stages. What is the phenological stages? Germination, emergence of seedlings, then emergence of appearance of tillers, then 50 of completion of vegetative phase, 50% flowering, appearance of grains, then physiological maturity, filling of the grains and physiological maturity, then finally harvest maturity. That means if we need to understand the phenology of the crop as well. The phenology of the crop depends upon the temperature and the length of the day most of the times. So they have they have developed theoretical concepts to monitor the growth of the crop, the development of the crop stages using temperature and the length of the day. So it is called phenological estimation. That means we can monitor the development of the crop from time to time, but knowing the temperatures from sowing to harvest. Actually, the the actual growth of the star and double star depends upon what is called a base temperature. That means the crops do not grow and undergo the phenological development unless there is a base temperature. There is a minimum temperature required for most of the crops. Usually, we take this base temperature as 5 degrees centigrade for the crops grown during winter season and maybe 8 to 10 degrees centigrade for the crops grown during rainy season and summer season. So what we do is, so every day we have to take the daily maximum temperature and minimum temperature. The average of the maximum temperature and minimum temperature, we call it as the daily mean temperature. Suppose today the main daily temperature is 30 degrees centigrade and you are growing a crop during summer season. The base temperature of the crop is 8 degrees centigrade. Then the difference between the day temperature and the daily mean temperature and the base temperature, we call it as degree days. That means 30 minus 8 is equal to 22 degree days. That means what we do is we go on accumulating degree days when the crop undergoes development stages from sowing to harvest. So usually for a crop like wheat, the growing degree days required maybe around 1500 or 1800 degree days, whatever it may be. So, by monitoring the degree days, and sometimes the degree days alone may not be able to account for the crop growth development. That means the different phenophases. It depends upon the length of the day as well. Because particularly in the Western countries like USA, Canada, those countries, you find the length of the day is much more, around 14 to 15 hours a day during summer season. So that there, the growth size, the phenology of the crop is estimated not using just temperature alone, but length of the day as well. So this is very important parameter. So what we can do is by using the weather data like temperature, length of the day, we can monitor the stages through which the crop undergoes development right from sowing to harvest. By monitoring water use of the crop and estimating the water used by the crop from sowing to harvest, we can estimate the total biomass produced. Actually, the economic yield, the grains or pods, which form part of the total biomass, we call it as economic yield. That economic yield, the ratio of economic yield to the total biomass, we call it as harvest index. That means suppose there is 40 uh, quintals of grain from 120 quintals of biomass. That means the harvest index is 40 divided by 120, that is equal to zero point 0.3. That means usually most of the C3 crops will have harvest index around zero point 0.3 to 0.33, and most of the C4 crops like maize and bajra, sorghum, they may have harvest index up to zero point 0.4. So it depends upon from crop to crop, but usually C4 crops will have higher harvest index compared to C3 crops. This is another thing. So what you have to understand is how the crop development takes place and how the grain development takes place and how do we estimate the total biomass and how do we measure the ultimately estimate the final yield. So what we do, the simple exercise of the monitoring the crop development and assessing it, plus the estimation of ultimate yield, economically important yield and total biomass produced by the crop, we call it as crop modeling. Crop modeling means from day to day basis, you measure how much of dry matter is accumulating, what changes in growth are happening, what changes in development of the crop are happening from time to time, and ultimately, using the weather parameters, we are able to estimate the ultimate yield that can be obtained by the crop when water is not a limiting factor and when the adequate fertilizers are applied. Naturally, the yield not alone does not depend just alone on the weather parameters. It depends upon the soil fertility, amount of fertilizer applied by the crop, and how much of it is used by the crop, and then the other factors that affect the crop growth are the biological interferences to crop growth. See, the crops usually what happens just as we enjoy sweets like laddu and jalebi, things like that. These insects also like to eat crops which are more nutritious and tasty. So you find the crop pests attack the pests, the insect pests start attacking the crops. The insect pests may be emerge from the soil. They may come from the local plants around the cropped area which are hosting these insects, and they may be allowed to go away when the crop is ready for them to eat. So these insects damage the crops considerably. But apart from that, insects, we also have the problem with the diseases. That means just like we get coronavirus or typhoid or infections, the crops also suffer from infections by bacterial, fungal infections. So the infection suffered by the crop, we call it as crop disease. So the crop diseases and the appearance of pests on the crops, that also to a large extent depends upon the stage of growth of the crop as well as the weather parameters. That means suppose there is hot and humid weather and with cloudy skies, you find lot of insect attack and you find multiplication of the bacterial diseases on the plants. So, what is more important is how do you monitor the occurrence of the crop pests and diseases using weather data? Then I tell you another example. For example, you know that there is a problem of wheat rust in Punjab area in India. That wheat rust, the fungal spores of the wheat that cause wheat rust are transported from Booty to Punjab. Booty is somewhere in the down south of India, in the peninsular India. And these fungal spores are carried through wind movement, atmospheric movement, from the Booty area to Punjab. That means they found that ultimately the disease of wheat rust in Punjab is related to the transport of fungal spores from the down south from peninsular India. That means there is this transport of migration of insects or transport of fungal spores through a medium of air and wind movement. We call it as spatial dynamics of insect pests and diseases. That means we have to relate the movement of the insect pests and diseases to the movements in the atmosphere associated with large scale weather systems. That is another important area of study, which is not done anywhere in the world right now, except two or three cases in Texas, in Michigan, and some of the America countries like America and Canada. They found that the rust occurs first in the lower latitudes and then it migrates towards the upper latitudes gradually. Similarly, in India also the wheat rust appears in lower latitudes of India and migrates to upper latitudes of the India. That means Punjab is at 26 degrees latitude and say Ooty is at 8 or 10 degrees latitude. So imagine this rust is carried by latitudinally by 16 degrees of distance. So you find that this is very another important aspect of the study. Then third is there are these pestle diseases. Sometimes they are very sporadic in nature. Certain pestle diseases we can predict the time of occurrence because these diseases and pests occur during a particular phenophase of the crop. So, for example, there is a crop like pigeon pea and there is a pod borer insect. That pod borer insect appears only after pod formation. That means you can specify, you will be able to forecast the occurrence of pod borer much easily because you know at what stage of it crop growth it occurs. That means we can somehow manage to predict the occurrence of the pest and diseases that occur during the initial phenophase, particular phenophase. And there are certain pestle diseases which occur sporadically in nature. That means you don't know at what stage of crop growth the pestle disease occurs. For example, whitefly in cotton. Whitefly in cotton may occur anytime after emergence of leaf to when even when the crop is under bolt formation and development. That means the sporadic pest and diseases are very difficult to predict because they do not occur regularly every year, but they occur at random in some of the years and also at random across in some of the regions. But the devastating effect of the sporadic pest and diseases is very high. That means we have suppose there is whitefly in cotton, it can destroy the cotton crop in a large area in the entire district or even state. It's capable of doing it. So the sporadic pest and diseases also cause considerable damage to the crops. So what we have to do is we have to develop techniques to predict the occurrence, development, the incidence, development, spread, and damage caused by the pestle diseases. That way, this is very very important. Third thing is we talk of agromet advisories. Agromet advisory means what? It is when the weather agencies, India National Meteorological Department gives you a weather forecast. You have to translate this weather forecast into actionable agromet advisory to the farmers. That means how to tell really what the farmer can do in his field based on the weather forecast, whether it requires any action, if so, what action is required, how to carry it more precisely, and so on. For that, what is happening all these years is it is just we are giving agromet advisories more based on our personal experience. That is, sometimes whatever advisory may give may fail or may succeed. So, based on personal experience means there is some guesswork involved. So, what is more important is these agromet advisory services, advisories have to be formulated by studying the impact of the forecast on the production system. Suppose the forecast says that there will be a heavy rain for 3 days continuously in West Bengal area. So you must be able to assess what will be the impact of 3 days continuous rain on a crop like rice, which is grown in West Bengal, for and which are the areas where there may be likely to be flooding, which are the low-lying areas where there may be flooding and damage to the crop, where which are the areas there may not be flooding of the crop and crop is comparatively safe. And suppose the rains are associated with strong winds, which are the areas where the crop is likely to get dislodged. This kind of things uh, uh, have to be assessed based on impact of weather forecast on the production system. Unfortunately, we do not have any kind of research to assess the impact of weather forecast on the crop production systems. This is very, very important area of research. Unless you develop a solid scientific basis for giving agromet advisory based on the weather forecast, it will be of very marginal use to the farmers. This is very much important. Third thing is, I always tell that you cannot learn agricultural meteorology just because you know what is rain, what is temperature, and what is humidity. That's not enough. You see, the agriculture meteorologist should have knowledge of reading the sky and the soil as well. He must be able to understand the soil, the crop, the production system, and also able to read the atmosphere more accurately. So you need to develop train people who can read the sky and soil simultaneously. With traditional agronomists often fail in rendering agromet advisory services. You need to develop a new brand of scientists called agricultural meteorologists who will synthesize all the recommendations that emerge from pathologists, entomologists, the agronomists, soil scientists, and so on, synthesize the recommendation based on the weather forecast and give a capsule to the farmers on what he can do in the field level. This is very, very important. Education in agricultural meteorology is very important. Secondly, what is happening is this agricultural meteorology is taught in most of the places by people who are not qualified in agricultural meteorology, not trained in agricultural meteorology. So what happens is when the trainer himself is not are you able to hear me? Yeah. So when the teacher himself is not equipped with the adequate knowledge of the science of agricultural meteorology, we cannot expect his students to do wonders. So what I suggest is normally it is our habit to deploy some existing people to teach the science of agricultural meteorology, although we know that they are not competent to handle the subject. That way we are doing great injustice to the subject, and this agricultural meteorology is not getting popular because more people who are not actually trained in agricultural meteorology are handling the discipline of agricultural meteorology. So my earnest appeal is to give importance to first get some faculty trained in well-established institutions and universities for a year or so. Then start teaching program. Third thing is, all these days there was a big vacuum in the literature. That means there were no proper books in agricultural meteorology to meet the requirements of our countries. So what we have done is we have tried to develop some textbooks which can be useful for the students and faculty as well for teaching meteorology or learning agricultural meteorology. But mastering the subject is very, very important. Unless a person is very good, it is just like taking treatment from a specialist and a registered medical practitioner. If somebody says headache, I will also tell them take Tylenol or paracetamol. But I am not a doctor. But I don't know what paracetamol may affect the patient if he has got other complications. So what happens is if you don't know the science properly and advocate prescriptions to the farmers will be at loss and they lose trust on the science. So agricultural meteorology has to be developed properly using well-trained personnel and giving very important more of practical training on how to use the weather information to monitor the effect on weather parameters on the field condition, assess what is the likely impact of the weather parameters, predicted weather conditions on the performance of the production system, and then formulate the advisory. That kind of approach is very much essential. Don't venture into the subject unless you have full confidence to deal with it. That's my appeal. Thank you.